Assalamu alaikum dear students, this is lecture 6. The topic of today's lecture is requirement gathering. This is the agenda for today's lecture: requirement gathering techniques, types of requirement documents. First we will study the different types of requirement gathering techniques. You can gather requirements from the same source of information as you use for domain analysis, that is from the various stakeholders, from the software systems, and from any documentations that might be available. The first gathering technique is observation. Observation is used to obtain important information that stakeholder may not think of telling you. The next three techniques are interviewing, brainstorming, and prototyping are complementary techniques for actually asking for the opinion and knowledge of stakeholder as well as forcing the stakeholder to state their mind. First is observation. Observation is the first requirement gathering techniques. You can read the documents and discuss requirement extensively with the user, but often only the process of observing the user at work will bring to light subtle details that you might otherwise miss. For example, in the retail applications, you may notice that the manager bargaining with the buyer over price of certain items. In an interview, they may forget to tell you that this is something that are to be automated. In its simplest form, observation means taking a notebook and observing important potential users as they do their work, writing down everything they do. You can also ask the user to talk as they work, explaining what they are doing. In other variations, you can videotape the session so that you can analyze it in more detail later. Observations and analyzing the resulting information can consume a large amount of time. Therefore, it's best done only for the development of large systems and with the potential user will be performing complex tasks. The second requirement technique is interviewing. Interviewing is a widely used technique. However, a well-conducted series of interviews can extract more information than poorly ad hoc interviews. Unfortunately, despite it being an important skill, software engineers are rarely trained in conducting interviews. The guideline should help you to perform these important steps effectively. First, plan to have as many members of the software engineering team interview as many stakeholders as possible. Considering go beyond the stakeholder, talking to the user of competing product, marketing personnel and people involved with other systems that may interact with your systems in any way. Spread out the interviews over time and allow yourself several hours for each interview, even if you do not expect to use that much time. Time between interviews will allow you to analyze that you have heard and think of additional questions. Leaving plenty of time, ensure that if the interview is providing lot of information, you can let him continue. For the most important stakeholder, you should hold a series of interviews going into more depth each time. This allows your knowledge and analysis to improve the interviewing periods. Prepare an extensive list of questions, although do not be disappointed if there is not enough time to have them all answered in a given interview. The third is brainstorming. Brainstorming is an effective way to gather information from a group of people. The general idea is that the group sit around the table and discuss some topic with the goal of generating ideas. However, as with the interview, adding some structure to the brainstorming process can help you to extract a large amount of information. One of the key to success is arranging for the brainstorming session is to led by some trained persons. The following is a guideline for running out brainstorming sessions. First is call a meeting with the representation from all the stakeholders. Effective brainstorming sessions can be run with 5 to 20 people. Appoint an experienced moderator, also known as facilitator, that is someone who knows how to run brainstorming meeting and will lead the process. The moderator may participate in the discussions if he wants. Arrange the attendees around the table and give them plenty of paperwork with. Decide on a trigger question. This is the key step in the process. A trigger question is one for which the participation can provide simple one-line answer that are more than just number or yes or no response. Example of trigger question include the following: what are the features important in the system? What future sources of data should we anticipate? What output should be produced by the system? What classes do we need in the domain model? What interview questions should we ask? What issues have we not considered? What are the risks or difficulties in this project? What trigger question can we ask? The trigger question can be determined by the person who called the meeting, that is the moderator or facilitator, by a quick discussions or brainstorming followed by a vote. Ask each participant to follow these instructions. First is think of an answer to the trigger question, no matter how questionable the answer is. Write the answer down in 1 or 2 lines on a sheet of paper, but there should be one idea per sheet. Press the paper to the neighbor on your left to stimulate his thoughts. Look at the answer passed from your neighbor to the right and pass these on your left as well. Use the idea you read to stimulate your own ideas. Continue step 5 until ideas stop flowing or fixed time 5 to 15 minutes passes. Moving around the table, ask everybody to read out one of the ideas on the sheet that happen to be in front of them. If anyone seeks an explanation, the originator of the idea may comment briefly, although he may choose not to say anything in order to remain anonymous. The moderator or secretary write each idea on the flip chart, then optionally the whole group may briefly discuss the idea. After a fixed time period, or after all ideas have been recorded on flip chart, the group may take a series of votes to give priority to these ideas. For example, every person may be given a fixed number of votes that they can allocate to the answer they think are most important. The main advantage of brainstorming is that the moderated group sessions, people can energize and tend to spontaneously invent many good ideas stimulated by what others have said. There are 2 advantages of using structured approach as described above. First, introverted or timid people can have their say effectively, since anonymously can be assured. Sometimes such people think that their ideas are not very good because they lack self-confidence. Second, a lot of thinking goes in a parallel during the first phase, everybody thinking of their own ideas and write them down concurrently. These sessions therefore more productive than if everybody had to wait their own idea to express. Prototyping. A prototype is a program that is rapidly implemented and contains only a small part of the anticipated functionality of a complete system. Its purpose is to gather requirements by allowing software engineers to obtain early feedback about their idea. The simplest kind of prototype is a paper prototype of user interface. This is set of pictures of a system that are shown to the customer and user in a sequence to explain what would happen when the system runs. It can often be very more powerful tool for extracting ideas and feedback, but it required a very little effort to create. Because paper prototypes are easy to create, they are ideal for parallel development. In parallel development, several software engineers independently create their own view of the system. The resulting prototype are then evaluated and the best feature of each become part of the system requirement. It's possible to carry out parallel development further than a paper prototype, but that takes more work. The most common type of prototype is a mock-up of the system user interface created using a rapid prototyping language. Rapid prototyping language allow you to create code very quickly in order to display the important parts of the user interface. However, they have various weaknesses that limit their usefulness for creating the final version of the complex system. These weaknesses include inefficiency and limitation on your ability to create robust and flexible design. User can sometimes make actual use of rapid prototype. However, there is often nothing much behind the user interface. It may not, for example, perform any computation, access any database, or interact with any other system. You should modify a rapid prototype as many times as necessary in response to the feedback from the user. However, you will not have to put effort in the designing its architecture. Therefore, it will become hard to maintain and will contain many bugs. Because of this, you should not normally turn it directly into the final system. It should be used only as a requirement gathering tool. Types of requirement documents. To perform good software engineering, it's always appropriate to write down requirements. The level of detail of the requirements can, however, vary significantly from project to project. At one extreme, there are documents that informally outline the requirement using a few paragraphs or simple diagrams. On other extreme, there are specifications that contain thousands of pages of complicated detail. Unfortunately, developers often slip toward either extreme. Choosing the right level of detail requires careful balancing, because too little detail can result in a system that does not adequately solve the problem, where too much detail can be a waste of time and can make the development process too inflexible. Frequently, you have to produce several requirement documents, each describing a different part of the system or different level of detail. When doing this, your strategy should be to make them all complementary. Each should refer documents as necessary, but there should not be redundancy between the documents. Redundancy leads to the contradictions when changes are made at one place but not other. Requirement documents for a larger system are normally arranged in a hierarchy level. There is a top level document describing the overall system. A subsystem, however, describes how the subsystems interact with each other. There are separate documents describing each subsystem and sometimes each subsystem. When we talk about the system, we are referring to whatever the current development teams are working in, which may be a system or larger system. How do you decide what type of document to produce and how much detail should be provided? The following factors are usually considered. The first is the size of the system. A large system will need more detailed requirements for several reasons. First, there is simply more to say. Second, the system will need to be divided into the subsystem so that different teams can work on each part. It then becomes essential that everybody have a clear idea of what everybody else is doing and how the subsystem interacts. The second is the need to interface to other systems. Even a small system will need to have well-described requirements if other system or subsystem are going to use its services or communicate with it. For example, you have to specify the protocol with which client and server communicates, otherwise you will have to able to get them work together. Third is the target audience. The requirement should be written in a high-level language so that the potential user can read it. If the system is intended for the general population, it should omit the jargons that would be understood by only few people. On the other hand, the system might be intended for the user with specific scientific or engineering background, in which case technical detail from their domains can be appear. Only if the system is strictly intended for use exclusively by other software systems, then it's reasonable to include detail down the level of algorithm, data structure and procedure. Normally, such level of detail would only be found in the design document. However, in certain type of utility packages, the distinction between requirements and design should be made blurred. The contractual arrangement for the development. If you are arranging a contract by which a third party will develop software for you, then you will have to specify the requirements with considerable precision. Similarly, if you are developing requirements under contract for a military client, for example, then you will have to follow specific rule regarding the formats and detail to be provided. The stage in requirement gathering. At early stage, the requirement gathering, it's important not to write large volume of precise and detailed requirements. The risk that these will have to be completely rewritten is too great. An outline describing a system or subsystem in a few paragraphs or pages may be best at this stage. Once all the stakeholders agree with the short informal statement of the requirement, a successive level of details can be added. Often it's best to develop a rough prototype based on a very short statement requirement is the first iteration of the system. You should then experimenting with the prototype, learning a lot of information about what is good or what is bad about it. You can add more detail to the requirements as you develop in the next iterations, which may have a more advanced prototype or a formal release of polished system. You should think of this process of repeatedly prototyping as an integral part of the requirement gathering process. The level of experience with the domain and the technology. If you are developing software in a very well-known domain and using a very well-known technology, then you should be able to produce a complete requirement document before starting to the design of the system. However, if you are developing innovative software, then more caution is needed. You should certainly develop prototype based on rough requirements to check out the validity of your ideas or the reliability of the technology. By technology we mean such things such as new programming languages, new libraries, framework, algorithms, hardware, databases or third-party software with which you are interfacing. The cost incurred if the requirements are faulty. Any system that if failed could harm safety or the environment must be precisely specified. Furthermore, those specifications should be subjected to thorough analysis and review. Examples of such critical systems include those control industry processes, which include telecommunication network, medical equipment and many consumer devices. The safety risk involved with nuclear plant and automobile is clear. The telecommunication network failure can also be pose a safety risk if people rely on them during the emergencies. Software failure in a consumer devices such as garbage door opener or washing machines could lead to an injury, fire or floods, not to mention severe financial penalties resulting from litigations. A famous example in software would not have been operated in the year 2000 had not been fixed. The requirement for the software written in the 20th century should have specified 4 digits dates instead of 2 digits dates. Software failure Thanks, it's enough for today.